Okay, Euler. Remember, you say this Euler, like Euler. Don't be saying Euler. Euler wanted to make a circuit. We know what a circuit is, right? It starts and ends at the same vertex. And he wanted to cross every bridge exactly once. So every edge he wanted to cross once, and he wanted to start and stop at the same place. So in the city he lived in, he just wanted to see if he could make it around. All right, so an Euler circuit is you want to have all the vertices can be repeated. Okay, so let's remind ourselves of this. You can repeat a vertex, but every edge exactly once. So you say at Euler, every edge exactly once for an Euler circuit. So is there an Euler circuit for this? Okay, so let me just get some red out here. And I'm just going to start with V sub 0. So if I start at V sub 0, and I'm just going to move over here to V1. And then I'm going to move here to V2. And then, right, it's not unique. And then I'm going to move here to V3. Then I'm going to move down here to V4. And then I'm going to move here to V2 again, because I can repeat vertices. Then I'm going to go to V5. And then I'm going to go back to V sub 0. So that's a circuit. I hit every edge exactly once. You get to do that one. Okay, oh, and you get to do these as well. So I've drawn the pictures for you. So do these have an Euler circuit? So I'll let you do those. All right, so Hamilton, think of it as a salesman. So Euler was in a town, had lots of bridges. He wanted to start and stop at the same place and get over every bridge, every edge exactly once. Hamilton, he needs to make it to every city, every vertex exactly once. He does not need to go over every single street, right, or every single highway, but he just wants to make it to every vertex exactly once. And, okay, so let's see. And he doesn't want to go to the same vertex, right? You don't need to include all the edges, right? So every vertex exactly once. All right, here we go. So what we want to be able to do to make our Hamilton circuit is if I have this G graph, I want to be able to make a subgraph that has these four properties. So H contains every vertex of G. So that means I'm going to have the A, the B, right? Because the A and the B, all of these are the cities that we need to get to. So I need to get to every one of the cities. There you go. Okay, so I need to get to every one of those cities. It's connected. Okay, so connected means I should be able to get from any vertex to another, right? Has the same number of edges as vertices. So 1, 2, 3, 4, 5, 6, 7, 8. So it should have 8 edges. And every vertex has degree 2. Okay. So I'm just going to start to think about, kind of moving along on the outside, right? Kind of like this, picking those pieces up so that I'm going to be able to get to, so A to B, and then to C, oops, and then here, and here, and I'm thinking, oh, look at that. That was pretty nice and simple, right? So every vertex has degree 2, right? 1, 2, 1, 2, and it's all connected, so I can get from vertex A, taking a walk to get to vertex E if I wanted to. So this is a Hamilton circuit. Oh, and let me draw some graphs in for you for this one. Okay, so Hamilton circuit still, we can say does not, a graph G does not have a subgraph if that satisfies the 4 properties if I cannot match one of these criteria, right? Okay, so what I want to be able to do is I want to always make the number of edges equal the number of vertices, or make all the vertices of degree 2, keep it connected, and keep every vertex, right? So all 4 of those. So if I cannot do one of these 4, then I can say there's no Hamilton circuit. All right, so let's count the number of vertices. 1, 2, 3, 4, 5 vertices. How many edges? 1, 2, 3, 4, 5, 6 edges. Okay, so if I take away an edge so that I have the same number of vertices and the same number of edges, then it's not going to be a circuit, right? So I cannot eliminate an edge and have a circuit. So no Hamilton circuit can be made here, right? Okay, so I'm going to have you do this one, and this one, and this one, all of these. I'm going to have you do all of these. So I'll let you look at those pictures, and I think that's it. Yes, that's all and then I just have a summary of facts down below.